Bismillahirrahmanirrahim. Assalamu alaikum. This is our lecture number 6 of unit number 9, Chords of a Circle. I am Rubina Khadim from Divisional Public School and Intermediate College, Lahore. Today we are having theorem number 5. Theorem number 5 states that two chords of a circle are equidistant from the center are congruent. If we have two chords of a circle having equal distance from the center, we have to prove that the chords will be congruent. Here in this figure, we have a circle with center O, AB and CD are two chords in the circle such that both chords are having equal distance from the center. OH is the perpendicular distance drawn from center to the chord AB. OK is the perpendicular distance drawn from center to the chord CD. OH is perpendicular to AB and OK is perpendicular to CD such that these distances from the center are equal. OH is equal to OK. We have to prove that the given chords AB and CD are equal. Theorem number 5 is the converse of theorem number 4. We have already studied that if two chords of a circle are congruent, then they will be equidistant from the center. Now, this theorem number 5 is the converse of the previous theorem. That is, two chords of a circle are given. We have to prove that the chords will be congruent if they are at equal distance from the center. So this is entirely converse of the theorem 4 which we have learnt already. AB and CD are two chords of a circle. OH is the perpendicular distance drawn from center to the chord AB. OK is the perpendicular distance drawn from CD. We are given that these distances drawn from the center are equal. Two chords are at equal distance from the center. We have to prove that the chords will be congruent, means AB is equal to CD. In construction, what we will do, we will join center O with A, center O with C. The construction is drawn here in dotted lines. Join A and C with center O so that we will have two right triangles OHA and OKC. These are the right angle triangles now which we have. In proof of the theorem, we have two parts, statements and reasons. We will discuss both triangles. We have two right angle triangles here, OHA and OKC. As we have drawn in construction, we have joined OA with OC, O with A and O with C. We have right angle triangles in the correspondence of two right angle triangles OAH and OCK. We have hypotenuse OA in the right angle triangle OHA. Side opposite to the 90 degree is always called hypotenuse in a right angle triangle. Hypotenuse OA is correspondingly congruent to hypotenuse OC of the other right angle triangle. Both of them are radii of the same circle. We are given that the perpendicular distances drawn from the center are equal. So OH is equal to OK. It is given. It is given to us already. So in hypotenuse side theorem, we have already discussed so many times that the side opposite to the 90 degree is hypotenuse. If a side and the hypotenuse of a right angle triangle are respectively congruent to the hypotenuse and the corresponding side of the other triangle, then the triangles are congruent. This is hypotenuse side postulate or hypotenuse side theorem it is called. So the triangles are congruent by hypotenuse side postulate. If two triangles are congruent, then their respective sides and angles are also congruent. It means AH, measurement AH is equal to measurement CK. These are the respective sides of the congruent triangle. We will write corresponding sides of congruent triangles. But we know that by theorem 3 that perpendicular drawn from center bisects a chord. So OH is perpendicular to the chord AB. It means AH is the half of the whole chord AB. Similarly, OK is the perpendicular drawn to the chord CD. Perpendicular drawn from center bisects a chord. It means OK divides the chord CD into two equal parts. So CK is the half of this chord CD. AH is the half of AB. CK is the half of CD. Both are having the same reason. OH is perpendicular to AB. Similarly, OK is perpendicular drawn to CD. Perpendicular from center bisects the chord. AH is the half of AB. CK is the half of CD. If two halves are equal, means AH is equal to CK, we will use number 2 and 3. It means half of AB is equal to half of CD. AH is equal to CK, as we have proved here. So AH is the half of AB, CK is the half of CD. If two halves are equal, then definitely if it will be doubled, multiply by 2 to the both sides, AB equal to CD, using 2 and 3 as we have discussed in previous, that AH is the half of AB, CK is the half of CD. If two halves are equal, then the whole chords are also equal. So students, this is the theorem number 5, which is converse of the theorem number 4. If you have already learned theorem 4, it will be very much easy to you to learn this theorem. Please, I'll suggest you, please revise these theorems again and again, because these theorems are very much important according to the examination point of view. These theorems occurs um, repeatedly so many times. So it's a request to you, don't waste your time and take keen interest in your studies. Hope for the best. We have done all 5 theorems of this chapter. This is the view of theorem number 5. In your book, it is at the page number 185. So kindly please prepare these theorems. Thank you.